How do I know if I'm getting them?
If they don't meet perfectly,
I can't
then
see.
guess what? It doesn't work. See if it works.
It's tiny.
Because some of your combinations probably won't work.
No, it's just, yes.
Do you know why?
Too small.
They're too small. Or in other words, they do not fit the theorem. Okay, remember what the theorem is. The sum of any two sides has to be greater than the length of the third side. Some of them will work and some will not. Michaela, you can slide your angle in so that your two meet. They should meet. Hopefully. Yes, that one works. Cordell, stop cutting, please. That's been recorded for posterity. They know who my problem child is now. Not you. Okay, so which ones work? Did y'all figure out?
Yeah, blue and yellow.
The blue and yellow. Are they
Red,
the only
yellow.
ones that work?
Yep, red and yellow,
You
blue
might
and
find
red.
another combination. Try another combination. We
Red,
know that blue and yellow works now, but what else?
red and yellow,
And you can change your angle
blue and
measurement.
red, and blue and red.
Blue and red does, yes
Yeah.
or no?
Mm-hmm.
It does. Is it all the way out to the edge, Linda?
No.
Ah.
Now it is.
Yes. Swing it in a little bit. It might work. Okay, so we know blue and yellow are a good combination. Red and yellow makes a good combination. Who does not work?
Green.
Green and what?
Green and anybody.
Green and anybody. Well, add it up and see. Remember, add up two sides. It's got to be longer than your third side. Any of them that any two put together is not longer than the third, guess what? Can't do it. And you have the perfect example of the windshield wipers. They're not going to meet no matter what you do.
Yeah. Never
They're not
gonna
going to meet.
Yep, they don't.
Okay. So if you added these two up, they're longer, but those two don't work, huh? They're not longer than the third. So it doesn't work. Your three has to have that relationship. Okay? So we just proved that two sides added together have to always be longer than the third side, or it cannot be called what?
A triangle.
Triangle. We can call it anything else, but he's not going to be triangle. His name might be Sebastian, but he's not going to be triangle. So that is one part that we are proving. Now, what about angles? Remember what we said with angles? What do the angles in a triangle have to add up to be?
180 degrees.
180. If it's 210, he cannot be called triangle. Okay? So, let's prove that.
That's
Flip
what I want.
your paper over.
That's what I want. Right there.
And we're going to make a triangle. We're going to do numbers. How would I do that, guys?
Divide, divide 60 3 times. Multiply 63 times.
Multiply 3. Oh. What kind of triangle is we talking about, guys?
The one with all the sides.
Even size. That's
Equilateral. Very good. When it's isosceles, two are exactly the same. Okay? Now, we're talking about angles, though.
Oh.
Remember what we talked about yesterday? Where if you have two, if you're thinking about angles, what's related to that angle? Who is the one that's related? If you back yourself up in the corner.
The one that matches.
The one that if you shine your flashlight straight across, it's going to be the wall that's across from where your backside is in the corner. Okay? There's a relationship between that. Okay? If all three of our walls on our triangle, or our legs, are different, what do you think is going to be true about those angles when you back yourself up in the corner? Are they going to be all the same? Or are they going to all be different? They're all going to be different. That's right, because there's a relationship. If two of your corners are the same, exactly the same. All of your sides should be the same. So, here's what I'm going to do. There's a perfect combination, okay? A 60, and a 60. That's your equiangular triangle. And guess what? If it's 60, 60, 60, all your sides better be the same too. They can be 1, 1, and 1. They can be 10, 10, and 10. They can be 100, 100, and 100. But all three are going to be the same. Okay? There's the other nice one that people like to use, a 45, and what does it have to? What does it have to be if I've got 45 and 45? What's the third one got to be? Yes, it has to be 90 because they have to add up to what number? What's the golden number for triangles? 180. That's right. Okay. I'd like you to pick. You can do a 60, 60, 60. You can do a 45, 45, 90, or you can make up your own. 22, 71, and something else that makes 80 with it. Let's see, 22 and 71 is how much? 93. That means that third one has to be 180 minus 93. Okay, and that would be, let's see, gotta borrow, that's 7, gotta borrow again, 17 take away 9 is 87 is my last one. You can make up your own just like I did. Take two numbers, any two numbers out of your head, gotta be smaller than 1/8, okay? One of them can be larger than 90. Okay, but the other two, you have to add them up. If they don't equal 180, we can't use them. I just made this one up, as I said, pulled out of the air. You can make one up or you can do one of these. What I want you to do is on your paper, you can use your protractor and draw me the triangle that matches your angle measures. Okay, so draw your triangle. If you choose the one that's 60, 60, 60, measure. Do you remember how to use these, guys? It's been a little while since we've used them. And some people weren't really sure sometimes.